All right. So we just talked about a critical value, and a critical value is a value on a number line. In order to determine whether we need to reject the null or we fail to reject the null, we need to take our sample test statistic that we calculate from our sample data and compare that to the critical value. When we compare it to the critical value, that'll tell us whether we're on one side or the other of the critical value, which tells us whether to reject or fail to reject the null. So with a test statistic, we collect sample data, we calculate a sample statistic like sample mean, sample standard deviation, sample variance, sample proportion, and we convert that into a test statistic. So the sample statistic becomes a test statistic when it's converted from, some kind of unit to a standardized scale, like a z-score, a t-score, a chi-square score, or an f-score. So what I've got here down below is how you would manually calculate test statistics. All right, so if your sample statistic was a single sample mean and the population standard deviation was known, then you would calculate a z-score, a z-test statistic using this formula on the right. So that would be composed of the population mean, the population standard deviation, the sample size, and the sample mean. You put all of those values in together, and then that gives you your test statistic from your sample data. And then you would compare this test statistic to the critical value. Now, if you had a sample mean and the population standard deviation was one unknown, then instead of using a normal distribution to give you a z-score, you would use the student's t to get you a t-score or a t-test statistic. And you can see a lot of the values here are the same. The only thing that's different is because you don't have the population standard deviation, you use the next best thing, which is the sample standard deviation. And if you were dealing with a hypothesis test where you had a sample proportion and the number of successes was greater than or equal to 5, and the number of failures was greater than or equal to 5, and you're dealing with a simple random sample, then you would be creating a test statistic on a normal distribution using these parameters here. And likewise, you can do it for standard deviation, in which case here you'd get a chi-squared test statistic. So, in this table, I'm showing how you would manually calculate each of these test statistics using these expressions on the right-hand side of the equation. And I have done that in the past. But what I've gravitated to is using your calculator to calculate those values instead. So you can see here on the left-hand side, if you had one sample mean and the population standard deviation is known, and you need to calculate this sample z test statistic, then in the Texas Instruments calculator, you hit the stat button, you go to the test menu, and you run a z test. And when you run a z test, it will give you your z test statistic right there. And you'll notice that this function takes as an input this population standard deviation right here. It takes the sample mean right there. It takes the sample size right there, and it takes uh, the population mean right here. Now, what it's looking at down here in this argument is this is what your alternate hypothesis is. So you want to make sure that you put down what your alternate hypothesis is. If it's not equal to, less than, or greater than this value up here. All right. Next, we're going to end up talking about a p-value. Okay, and the p-value is this number right here where it says p equals. Okay, so just keep that in mind. Now on the NumWorks calculator, when you're trying to calculate the same thing, instead on the NumWorks calculator, you're going to go to the inference app, go to one mean, and do a z-test. So notice that these are both z-tests on both calculators. And you can see it's asking for the same information: the sample mean, the population standard deviation, the sample size. Let's see here. This one's asking for significance level, and it too will output the z-test statistic, which is the same number that we got up here with the Texas Instruments, and it also gives the p-value. Okay. So we'll be using this z-test function on both calculators. If the population standard deviation was unknown, then instead of doing a z-test, you'll do a t-test. Okay, and the t-test looks very similar, except instead of a population standard deviation, it wants a sample standard deviation. And instead of a z-test statistic, it gives a t-test statistic. Okay, as well as a p-value. The same is true with NumWorks, right? It asks for a sample standard deviation, which you give it that, and it gives you a t-test statistic and a p-value that goes with it. And if you're dealing with proportions, there's a one proportion z-test. And with NumWorks inverse app, go to one proportion, and then you do one proportion z-test. And you can see with this one, it's asking for the proportion that you're testing, the number of successes, and the sample size. Number of successes, sample size. Here, this one's asking for significance level. And then it outputs a z-test statistic and a p-value. A z-test statistic and a p-value. Okay, so we'll be using a calculator to calculate these values, the test statistic and the p-value, instead of manually using these equations. Okay. That'll be different from what I've done in the past. All right, so next we'll talk about p-value. Let me know if you have any questions.